Hello everyone and welcome to another one of Miss Claire's instructional videos. So today we're going to talk about double number lines with percents, and we just talked about Jackie Robinson and the scoring record. I'm not the best at baseball, so you'll have to bear with me. But Jackie Robinson scored on 52% of his times on base. So we walked through that in the simulator trainer, right? With this table. And we've worked with ratio tables before. Let's talk about how to work with them using double number lines. So it's kind of just like you translate it over. So if we have 52 for every 100, because that's what a percent means, right? 52 for each 100. We're starting with both of our ratios being 0. And we know that the number of scoring runs goes up by 52. It can go up by other numbers, but we're starting going up by full 52s. And the bottom number times on base goes up by hundreds. Again, can go up by other numbers. We'll see that in a second. So if we double that, then we have 104 times on base out of 200, or 104 scoring runs out of 200 total times on base. Then they said we had that extra 10. We had that 210. So this little distance here, we're going to call that 10 out of 100. So what that means is I have 10, or for the times on base at least, that's 10 out of 100. So I need to take 10 out of 100, or 1/10 of my number of scoring runs. So 1/10 of my number of scoring runs, 1/10 of 52 is equal to 5.2. So when we add this together, this gets to be 210, because that's our 10 out of 100, right? And this gets to be 109.2, those little red lines right there. Let's talk about this in a different context that I might understand a little bit more than baseball. So Aunt Susan has a hard time sealing canning jars. She has a 72% success rate with sealing her jars of jam. If she's planning on making 230 jars of jam this holiday season, how many can she expect to be correctly sealed? So we've drawn our two equal lines to represent the ratio. I also drew the ticks in there. Of course, starting at 0, like we did before. Then we're going by increments of what? We have 72%. Before we had 52%. So we know that for the number of sealed jars that we have, not 52, I was just going to say 52 because that's what I just said, but it's 72. We know we have 72 sealed jars out of the total 100. Swapped it there, but it still works because all that matters is the number that we're looking at, or the number that we're looking for, and having them on top or on bottom doesn't matter. So if Aunt Susan attempted 100 total jars, then 72% of them would be sealed. If Aunt Susan attempted 200 total jars, well, it's 72% of 200, that'd be 144. And if Aunt Susan attempted 300, which she didn't, that would be 72 times 3, which is 216 in total. But Aunt Susan attempted 230. So we need to add 30 more jars, right? 30 out of 100 more jars. So 30 out of 100, that's equal to 3/10, right? So now we need to take 3/10 of 72, which just so happens to be 21.6. So, which we also could have figured out by doing 216 over 300, move the decimal place over 1. But that means we need to add another 21.6 to our 144, which means our 200 jars attempted, which will get us a total of, I'm going to bring this down here, 165.6 sealed jars, roughly. So the value that we're looking for is our 230. And we determined that that little red line was our 30. And when we match it up with the number line below, we get 165.6. So Aunt Susan will correctly seal, well, that's almost 166. I'll give Aunt Susan the benefit of the doubt. I'll round that up. So Aunt Susan will correctly seal 166 jars of jam of the 230. So we can also write this as a proportion. We can write and solve this as a proportion, which y'all have learned how to do. If we know that we have 72 sealed jars out of 100, how many sealed jars will we have out of 230 jars? So you're going to finish up this problem, and then you're going to come tell, or I mean, you already know the answer, but you're going to show us your work in the formative. Thank you for bearing with me for another instructional video.